In this video, I'm going to go over how to evaluate inverse trig function. Now, what we need to remember about these types of expressions is that each of these functions, cosine inverse of x, sine inverse of x, and tangent inverse of x, there's only one input value that gives a single output value. So that's the first thing to remember. The second thing to remember is what the range is for each of these trig functions. Each of them is a different range depending on which function we're talking about. So for cosine, the range or the output value of inverse cosine of x is between 0 and pi. Okay, one way to think about this is that if we're on the unit circle, 0 to pi would be angles in between or contained in quadrants 1 and 2. For inverse sine of x, the output value is going to be between negative pi over 2 and pi over 2. So if we're thinking about this on the unit circle, negative pi over 2 is down here, pi over 2 is up here. So it's as though we're talking about quadrants 4 and quadrant 1. And then same idea for tangent inverse of x. The only difference is we have these inequalities that are just less than symbols, so we don't include those endpoints. So on the unit circle, everything is the same as what we had for sine, except we're going to have open circles on the endpoints there. So let's look at a couple of examples, keeping all of this in mind. For this first one, we have cosine inverse of root 3 over 2. Now, when we're talking about inverse trig functions, the input value, root 3 over 2, this is a coordinate, and the output value is going to be some angle. So what this question is asking is, what angle has a cosine value of root 3 over 2? Now, remember, if we think about the unit circle, there are two positions on the unit circle where cosine is a positive root 3 over 2. It's at this position and this position. So if we're thinking about this in radians, we would say pi over 6 and 11 pi over 6. However, thinking back to our rule, we need this function, this inverse cosine function, to only have one output value, and the output value must be in the range we talked about. The range for cosine is in quadrant 1 and quadrant 2, so pi over 6 would be the value that we want here. If you give pi over 6 and 11 pi over 6 as the answer, that is incorrect. You need to only give one value, because all functions for a single input have a single output value. That is the basic definition, or that's part of the basic definition of a function. So we must only have one output value here. All right, let's look at two more examples. Okay, for this one we have inverse sine of negative 1/2. Again, this is now asking what angle has a sine value of negative 1/2. Well, thinking about the unit circle, sine is negative in quadrant 3 and quadrant 4. Negative 1/2 is going to be in these positions. This is 7 pi over 6, 11 pi over 6. So thinking back to the range for sine, we want to be in quadrants 1 and 4. So it looks like it would be this angle, 11 pi over 6. However, 11 pi over 6 is not in the range that we want. 11 pi over 6 is bigger than pi over 2. So instead of 11 pi over 6, we're going to say negative pi over 6. So this value would be negative pi over 6. So again, if you give two values for this answer, 7 pi over 6 and 11 pi over 6, those would be wrong. Also, if you simply put 11 pi over 6, that would be wrong because it's not in the range. So just negative pi over 6 would be this answer. All right, the third one we have inverse tangent of negative square root of 3. So again, we want to know what angle has a tangent value of negative square root 3. If we think of the unit circle, tangent is negative in quadrant 2 and quadrant 4 in these positions. In quadrant 2, that angle is going to be 2 pi over 3. In quadrant 4, that's going to be 5 pi over 3. Thinking about what the range is for inverse of tangent, we're between negative pi over 2 and pi over 2. So we want the angle that's in this position. However, 5 pi over 3 would be, it's too big because we would go all the way around the circle to get to that value. So instead of going counterclockwise, we're going to go clockwise to get to this position, and that angle is negative pi over 3. So that would be the correct angle. Again, only one value for the output, and it must be in this range.